So in order to add or subtract fractions, you need to have a common denominator. So once you get a common denominator, then you can add or subtract. This first one already has one. So it's over 9 and it's over 9. So then what do? I just rewrite the denominator and do the operations to the numerators to the top. So it's all over 9. And then on the top, I'm going to have 5 minus 2. That's 5 minus 2. 3. 3 over 9. What can I reduce that to? 1 over 3. B is not as nice because we have a 3 in the denominator and a 5 in the denominator. So 2/3 and plus 2/5. 3 and 5, what's common to 3 and 5? Remember when we make common denominators, we make them bigger, not smaller. 15, exactly. Now, I can't just multiply a top number by something and not the bottom. So I'm going to multiply both this one and this one by 5. And the reason why you do that is because this is technically 5 over 5. What's 5 divided by 5? 1. When you multiply something by 1, does it change it? No. So that's why you have to do to the top and the bottom, because indirectly you're actually multiplying by 1, and 1 doesn't change it. But if you multiplied only the top by 5 or only the bottom by 5, you completely change the equation. Okay, so you have to do it to the top and the bottom. So we're going to multiply this one by 5 over 5, and we're going to multiply this one by 3 and 3. Then we'll have common denominators of 15. So on the top, we have 5 times 2, which is 10 over 15, plus 2 times 3, which is 6 over 15. And so it equals all over 15, because we have a common denominator now. And then we just do the operations to the top. 10 plus 6. So you get 21 over 15. What does that reduce to? Oh, where in the heck did I even get 21? I need sleep. My kid had me up a lot last night. I'm done. 16 and 15. Does anything reduce out of that? Yes, it's 21. Exactly. Okay. I obviously did 6 plus 15 for some unknown reason. I don't know why. Got it wrong? Yeah, 6 and 10. It's 21. Don't you know? 6 and 4. What's common to 6 and 4? Someone usually always says a too big of one. What's common between 6 and 4? Smallest. 12. Most people say 24 because they just go 6 and 4, right? You want to do the smallest. The only reason why is if you do larger, which is fine, you're just going to end up canceling them off at the end. So you give yourself more work. Okay? So 12. We're going to times this one by 2 and 2. And we're going to times this one by 3 and 3. So we get 2 times 5, which is 10 over 12, minus 1 times 3 over 12, so 3 over 12. It's all over 12, so we can write it all over 12. What's 10 minus 3? Oh, it's going to be the running joke. Okay. It's 7. Can we break it down? No. We're done. All right. So those are your basic fractions, and you're not going to be doing basic fractions in this rationals unit. Rationals always have variables in them at some point, right? That's how it makes it a rational number or rational expression. So we're going to go over basic ones first where we don't have actual variables in the denominator. So same deal of what we just did above. And then we're going to go over harder ones on Monday where you have to make common denominators when they do have a binomial in the denominator, so 2 terms. Okay, so 2x over 3 minus x over 3. It has a common denominator, so we can just do what's asked of us, right? All over 3. So we're going to get 2x minus x over 3. What's 2x minus 1x? Just x. What's great about the fact that there is no variable in this denominator? A lot of things. One really big thing, we don't have to state NPVs. There aren't any. That denominator can't be 0. It's 3. You only have to state NPVs when you have a letter in the denominator variable. 2x minus x. So it's like 2 apples minus 1 apple. You have 1 apple. 3x over 4 plus x over 4. So it's all over 4. So you're going to have 3x plus 1x. What's up? What's your question? Because you're collecting like terms. So treat the x like it's an apple. I have 2 apples. I subtract off 1 apple. I'm left with 1 apple, or I'm left with that, yeah, 1 apple. So whenever they are the same variable, you can combine them, right? If it was like 2x plus 3, let's say, it would stay 2x plus 3. You couldn't combine them because they're not like terms. So 3x plus 1x, 3x's plus 1 more x is 4x's over 4. And then that can reduce to what? X. Try C and D. Try D only if you have a pencil. Try C for sure. Try D only if you have a pencil.